In this video we will talk about brakes. First we will look at band brakes. So this is the figure for band brakes, and this is the lever where it is hinged at one end and you have to apply load P at other end, and there is one drum which is rotating with some angular velocity omega. So you have to stop this drum by applying the brake and by applying the load P at this lever end. So this lever end is connected with the two ends of the rope. So this is one single rope or some band which is wrapped around this drum, and if you apply the load, this band will have friction at the drum and it will come to stop. So this is how you have to apply the brake. Now this rope or drum, if we want to cut, there will be tension T1 T2. So here omega is in this direction, so there will be more tension on this side because it will try to have a drag with the surface. So here this rope or band has more friction as compared to this side. When you apply the load, it will come into contact, it will have friction. So on this side there will be tension more because this drum is trying to pull here, and it is slagging here because omega is on this side and rope is also on this side. So on this side it will try to have more friction, and that's why it is having more tension on this side. So now if you want to analyze this, then there will be T1 tension, and on the other side there will be T2. So here T1 is more than T2 because the rotation is in this direction. And now the radius of the drum is R. The angle of wrap means from the contact point on one side to the other side, the entire band, the angle formed at the center, which is theta, which is the angle of wrap or angle of contact between this band and the drum. So now theta we know, that is angle of contact or wrap. Mu is the friction between the band or the rope and with the drum. So this rope friction with this drum is the coefficient of friction, that is denoted by mu. And we know that T1 is greater than T2, in this particular case omega. If omega is reversed, then tension direction will also be reversed, so T2 will be more in that case. Now we have simple relation T1 by T2, which will be equal to mu theta. This we have to remember for this particular problems, and we have to put theta in radians. So the torque generated, torque will be T1 minus T2 into R. If you take the difference and multiply by the distance, then that will be the torque that is to be applied. Now we can also analyze this lever by simple taking moment at O point. If we take simply moment at O point, then here also if we see here tension 1, if you draw the free body diagram of this lever, tension 1, here tension 2, and if we know the particular angle, this angle and this angle, we can take moment at O and we can find the relation between T1 T2 and P. So this is how we can find by taking moment at O. So this is how we have to analyze this band brakes, and if other values will be given, you have to find either T1 T2 P or some other parameter which is given in the question. So this is how we have to analyze. And the other brake we will see is the shoe brake. So in shoe brake, if we look here, there is same lever which is hinged at O, and we have to apply load at P point. Now there is one drum which is rotating with omega angular velocity, and there is the shoe. This hashed part is the shoe which is attached to this lever, and when we apply the load P, this will have a normal force on the drum, and it will due to friction it will try to stop the drum. So this is how we have to apply the brake. A is a distance from the center of the shoe brake and the hinge point, and B is from the center of the shoe till the load applied, which is P. The C is the height of the shoe from the center, from this O point center line to the where the friction average friction is applied. So this distance is vertically C. Now if we draw the free body diagram of the drum, there is a normal force applied on the drum by this shoe, and omega is in this direction. So friction on the drum will be in opposite direction. Now the same two forces, due to Newton's third law, action reaction, it will be applied on this shoe. So here normal force in opposite direction with same magnitude, and friction force we also have to draw opposite to the drum friction. So here friction will be in this direction. P load we know we are applying at the end point, and we know the distance is A, B and C. Now if we take If we take a moment moment at O equal to 0, then we can simply write P into total distance A plus B minus in the other direction minus, because it is in upward, P is downward, so P if we take positive, N will be negative, so N minus N into A. And friction is also rotating it counterclockwise, same as N, and opposite to P. So P is giving moment in clockwise direction, N and F are giving in anti-clockwise direction. So F into C. C is the distance from O to the average line of the average friction line, and the point O. So it's vertical distance. So this is how we can write this first equation. So and we know the friction will be equal to mu into N, where mu is equal to friction coefficient between shoe and the drum. So we have one equation, F is equal to mu N. We have second equation from the moment, and third, torque will be equal to friction times the R, because N is passing through the center point. So torque will be simply equal to friction into R. So R into F, and we know F is equal to mu into N, so torque will be equal to mu and R. Here also N, we have formula F and R relation, we can put that, and from that we can find P and F relation or P and N relation also, and A, B, C will be given in the question. So this is how we have to analyze shoe brakes. So these are the types of brakes which are generally asked in examination. And thank you for watching this video. I'll see you in the next video.